Hi guys, welcome back to In Case of Econ Struggles. Today I'm going to do another Edgeworth box example problem. I'm going to do the one where I talked about in a recent short, where you've got Aang and Katara. Each of those two people have 1 kilogram of cheese and 1 loaf of bread, and those are going to be the units for cheese and bread. Aang and Katara each have different utilities, and what we're trying to do is we're trying to find the equilibrium price and the equilibrium allocation for this Edgeworth box trade. Thinking more broadly, we've been thinking about both equilibrium and Pareto optimal allocations, and so eventually we are going to use this example to find sort of the Pareto optimal allocations. That's going to be in a future video. In this video specifically, we're just going to focus on finding equilibrium prices and equilibrium allocations. So if I think about the Edgeworth box, again, I've talked about how to draw an Edgeworth box sort of in previous videos. I'll put a link to a video in the description below just in terms of reviewing the Edgeworth box, and it'll also pop up in the right-hand corner right about now. But basically what we're trying to do is we've got bread and cheese, we've got Aang and Katara, they've got indifference curves. We're going to start with this endowment, and we're going to think about where we want to go in terms of what is going to be the competitive equilibrium. So the competitive equilibrium maybe is right here at X star, and so that's what we want to find. We want to find this allocation and the prices that make this allocation happen. And since we're doing a competitive equilibrium, let's just start by defining what exactly competitive equilibrium is, just as a good review. I've got a video on this as well that I'll put in the description below and in the top right hand corner right about now. But a competitive equilibrium in this case is an allocation where Aang gets some bread and cheese, Katara gets some bread and cheese. That's going to be given prices PB and PC, and the allocation and prices need to solve both Aang and Katara's utility maximization problem, where we're just maximizing their utility, and it's going to be subject to their budget constraint. Their budget constraint is just going to be this is how much money they have, because this is their endowment, and then this is what they spend in terms of they're going to trade their endowment for their allocation at these prices PB and PC. And we're going to satisfy market clearing such that the amount of cheese we start with and the amount of bread that we start with is equal to the amount of cheese and the amount of bread that we ultimately consume. We're not going to leave anything on the table. We're not going to try and consume, say, 3 bread when there's only 2 bread. So roughly the way this is going to go in terms of solving for this equilibrium allocation is that first we're going to find Aang and Katara's demand for bread and cheese, and we're going to do that as a function of prices. So we're not going to input any actual prices. We're just going to solve them as functions of prices. Then what we're going to do is we're going to use the fact that that market clearing means that our aggregate demand for bread and cheese needs to be equal to our supply of bread and cheese, or an aggregate endowment. That's going to tell us what the prices are. Once we have the prices, those prices are going to go back into our demand functions. It's going to tell us what ultimately our equilibrium allocation is going to be. So we'll just go ahead and we'll start with Aang's demand. Now I'm not going to use the Lagrangian here. All I'm going to use is that I know that at the optimum, the marginal ratio of substitution between bread and cheese equals the ratio of the prices. And the marginal rate of substitution is just the marginal utility of bread over the marginal utility of cheese. Again, you could flip this too. You could do cheese over bread, and that would be fine. But this is the way I'm going to do it. And so here is the marginal utilities. I'm just going to simplify these a little bit. And remember, with exponents, if this is xac to the 2/3, this is xca to the minus 1/3, then that would be 2/3 minus minus 1/3, which is just 1. Same thing for xab. That's how it ends up on the bottom there. And then, just for fun, I'm going to solve this for xac. I'm going to get that Aang's amount of cheese is just twice Aang's amount of bread times PV over PC. Now once I have that, I have a budget constraint for Aang, where these are the endowments. He's got 1 loaf of bread and 1 kilogram of cheese. And I'm just going to plug this guy in for xac so that this whole equation is in terms of bread for Aang. When I do that, I'm going to do some algebra, and I'm going to get to this point right here, where the amount of bread that Aang wants, or that Aang demands, is 1/3 times PB plus PC over PB, where this is really his wealth or his income, because that's how much his endowment is worth at the given prices. And so just sort of as a progress check, so you can kind of understand what's happening, remember these are our 2 market clearing conditions. I've found Aang's demand for bread and Aang's demand for cheese, where Aang's demand for cheese is just twice Aang's demand for bread. And so I'm just going to plug that in just like this. And so now what I know is I know that 2, or the amount of bread total in this world, has to be equal to Aang's demand plus Katara's demand. I don't know Katara's demand yet. Same thing for cheese. And so now if I solve for Katara's demand for bread and cheese, I'm going to get to what I need in terms of figuring out prices. Okay, so now I'm going to do the same thing and I'm going to find Katara's demand for bread and cheese. The only difference here is I'm going to use the Cobb-Douglas shortcut, where what we're going to have is if I have that u is equal to x to the alpha, y to the beta, that tells me that x star is just alpha over alpha plus beta times the amount of income divided by the price of x. So here alpha is 1/6, beta is 1/3. So here's alpha over alpha plus beta. And then income, I've got one bread and one cheese if I'm Katara. So if I've got 1 and 1, so here's my income. Here's the price of bread. And so this is my demand for bread. And again, very similarly, here's my demand for cheese. So now what I can do if I want to is I can use this thing called an excess demand function. Excess demand function is just total demand minus total supply. And we know that in equilibrium, that's got to be equal to 0. So what I'm going to do, just to be a little different because some people use excess demand functions, is I'm going to plug all these demands into my excess demand function, and I'm going to set those equal to 0 in order to find my prices. The other thing I'm going to do is because these are relative prices, right, it doesn't matter if PB is equal to 2 and PC is equal to 4. That's the same as if PB is equal to 1 and PC is equal to 2. Because they're just relative because I have bread and cheese. So whether or not the prices are like 10 and 20 or 1 and 2, it's not going to matter. So I'm just going to set PB equal to 1. That's called normalizing one price. So I'm just going to normalize the price of bread. Now when I do that, I'm going to again plug in my demands, set them equal to 0. And then I'm just going to solve for PC. And I'm going to get that PC is twice the amount of price of bread. And what I'm going to do is I'm just going to check that in the demand for cheese. And so I'll plug 2 in, and lo and behold, the excess demand is going to be 0, or total demand is equal to 2. And so that works for me, and so I know that these prices are the equilibrium prices. Okay, well now what I can do is I can take those equilibrium prices, and I can plug them back into demands. And if I do that, what you're going to see is that if I just take this one, for example, this is 1/3 times 1 plus 2 over 1. And so this is going to be equal to 1. And so what's going to happen is Aang and Katara each have one bread. They each have one cheese. So the equilibrium price are 1, 2. The equilibrium allocation is the amount of bread that each person eats is 1. The amount of cheese is also 1. So again, that's the competitive equilibrium allocation in this case. What we're going to do in the next couple of videos is we are going to think about what the Pareto optimal, the Pareto efficient points are. In order to do that, we're going to need to delve into the social planner problem a little more in depth, and so that's what I'm going to do in the next video in this series. So if you want to be notified, make sure to subscribe, make sure to hit the bell. If this video or these videos in general are helping you out, please like and subscribe. If you've got questions, leave that in the comment section below. We'll see you next time for another case of Econ struggles.